So they had a lot of information prior to evacuation. They knew they were going to jump down from a height. They knew they were going to rotate the flows. They knew everything that was going to happen before they got into the train. And because they couldn't see any smoke or fire, there was no immediate threat to them. So they're more willing to wait for the occupants to go through the tunnel or come off the train, which wouldn't be the case normally in an experiment. If you see smoke and fire, it would alter the human behaviour aspect of the flow rate. And because they're repeating the experiments over and over again, as you can see the queue of the people going in for group A, it affects the reliability of the results. Participants become more comfortable and it reduces the urgency to evacuate from the experiment. And also, as you can see with this guy on the left, on the right hand side, he's putting his hand on the wall. When I watched him through the video, he didn't do that for the first 2 attempts, and then he saw someone else do it. So he continued doing it, and then afterwards everyone else continued doing the same thing. So the flow rate increased significantly towards the end of the experiment. So the current model, the number of occupants was a major factor. In the paper in the book, it shows when I model a different number of people within the experiment and how it alters the flow rates. The way I calculated was I took 5 minutes and times it by my average flow rate that I used, and I ended up getting 120 people within the train, which seemed to work well with the value that was produced from the experiments. This might be risen partly by charts, so I have to do some more work on the capability of the program itself. At the moment, if this model works with this factor, it could possibly be used for other evacuations from heights. That is part of the future work. I'm hoping that it will be able to use, because most models I see don't really have a factor for jumping off an evacuation height, and they normally just assume it's level and it just kind of blows off. Like, for example, steps. They just kind of jump down, but there's no effect from the height. They just go and leave. I don't know about FDS itself. I haven't used it, sorry, Gemma. Not yet. Maybe one day. So coming back to the question, can an engineer using a current simulating modelling program produce evacuation flow rates of a line of emergency evacuation, a priori to analysis of the evacuation? In my case, yes. But if I had more dominant pre-movement times, then no. Pre-movement time, because of the whistle, it took it away. And I couldn't predict the pre-movement time. I tried predicting the pre-movement time with an actual live evacuation, and the model did not work at all. So it comes down to the fact that if you remove behaviour, then this model works, but unfortunately you can't remove behaviour from an actual live evacuation, only experimental evacuations. Yeah, any questions?
So, thanks.
Nice and quick.
So we have plenty of time, some questions, so please.
Yep.
Back there.
Did you consider in the experiments passengers carrying different luggage or baggage or hard baggage or something like this?
Well, the students that we had who'd come along, there's a wide range of people. We had a girl wearing high heel shoes and a mini skirt, so she evacuated slightly differently to someone who was wearing jeans. We had someone who had their luggage with them because they just got off the plane. So all that was in there, but I agree, if they're on the train waiting for work, there'd be more heavy jackets, there'd be more baggage. That's why I say that you can't really use this model yet for a live evacuation, because I haven't yet tested the fact that there might be altering factors within that experiment. But we did have a wide range of outfits and people's shoes. The most important thing was what they were wearing. Halfway through her experiment, she took off her high heels, because she knew she had to jump down again. So that was the learning behaviour. She took off her high heels and then used the wall. It would alter the evacuation speed. That's why they had the learning effect. They got quicker towards the end, so they knew what they had to do. So that, yeah.
I think I understand you because it was really, really fast.
Sorry. New Zealand accent.
We discussed it later.
Yeah.
Any other questions?
Yeah, you.
Yeah. When you said they were doing repeats, were there a long gap in between the repeats, or did they just cycled around?
They just cycled around.
Because was there any sort of suggestion of fatigue, sort of reducing the learning benefits?
Well, because the scenario that I modelled was at the beginning of the 3-hour experimental day. By the time they got to scenario 8, they actually had guys racing their friends through the train, climbing over the seats. They actually broke one of the cameras of their head because they jumped over the train seats just to change up for the day.
Right.
So that experiment had to be pushed to the side because they didn't have the right equipment for it. We had one person, we had this experiment with a ladder in the tunnel, and halfway through that they put it up against the wall and it actually hit a girl in the head, so we had to stop the experiment for a couple of minutes while we got her out of there because she got a concussion. It was quite brutal towards the end of the day. They started to misbehaved, I guess is the best way to say. So I couldn't use any evacuations from later on in the day because there was just too much.
So fatigue wouldn't have been too much of an
No.
issue earlier.
They were doing 5 minutes, then going off for a break, and then we changed experiments, and they come back, and then they had a half an hour break during the day for lunch and coffee, so they came back more energized than before. And then after that, we also changed the floor height to 0.75 into 0, so that it went from the tallest to the smallest. So there could have been a fatigue, but we didn't quite see it.
So, Dave.
Yeah, just come back onto your algorithm for the
Yeah.
relationship between the amount of the step down. I mean, you've only really got 1 point on it, is that right? You've got to do one line.
Well, because of the results are being published in December, I wasn't committed to show more results. I have done the correlation to the other results, and they are looking pretty good for the evacuation.
So you're sort of saying that from horizontal,
Yeah.
a small change in height has a relatively big effect on flux.
Yeah. Especially when you've got queuing, people behind you waiting to get down.
So the difference between, say, a 1 metre step and a 1.4 metre step is small.
Well,
It's
once
less.
yeah, there's a bigger drop between 0.5 and 1 metres because they start going from, I can just step down to, I have to do
So
something.
it's sort of sigmoid or something?
Yeah, it eventually should be like that. I think my graph is a bit too, because of the factor I used, the graph kind of went perfect shape down.
And did you look at have you looked at some quite small steps then? Sort of like, I don't know, like a normal step size? Or?
Not with this experience, we looked at
What kind of
0.
step sizes have you looked at?
Within this experience, we had 0 metres, 0.75 and 1.4. And then within the lab at university, I've got plans to do for the other heights as well. That's coming on in the next couple of weeks at Evacuations.
That's right.
Yeah, I have one question. So about the students or persons. So did you measure the height? So how tall they were?
We looked at the height because we had incremental sizes on the side of the video camera. So when they went past the step, you could see when they were standing how tall they were. The shortest person we had was 1.4 metres, and she was more reluctant to sit down and then jump off than to actually do what the other people do. But the taller guys would just leap off and just walk out.
Yeah.
So we had to look at the effects of height of the people. With the model I'm creating at the moment, we've got a colour factor of about 2 metres, so people can actually stop and won't evacuate out by 2 metres.
Yes, there must be a point where...
Yeah, about 2 metres we saw. We asked the question afterwards what height would they be comfortable for. And they said 2 metres was the maximum they would be comfortable for before jumping off.
Yeah. So let's thank our speaker once again.